So, what is math? Where does it come from? It's a simple question, but the answer gets complicated fast. People have been arguing about it for thousands of years. The debate really comes down to two main ideas. One side says we invented math, the other side says we discovered it. Think about the number 3. Is 3 a real thing? Or is it just a symbol, a word we made up? You can see 3 rocks, 3 trees, 3 people. But can you see the number 3 itself floating out in space? No. So maybe we just invented the idea of 3 to describe a pattern we kept seeing. It's a useful tool, a label, but then think about a triangle. If you have a right-angled triangle, the squares of the 2 shorter sides will always add up to the square of the longest side. This is the Pythagorean theorem. It works every single time. It worked for the ancient Greeks who wrote it down, and it will work for anyone in the future. It would even work for aliens on another planet. That feels less like an invention. It feels more like a fundamental rule of how space works. We didn't create that rule. We just found it. So which is it? Is math a tool we built, like a hammer? Or is it a part of nature we found, like a mountain? This question goes deep. It's not just about numbers, it's about our relationship with the universe. Are we creators, making sense of chaos? Or are we explorers, uncovering a pre-existing order? Let's start with the idea that we invented it. This view is pretty straightforward. It says that math is a language. Humans are good at creating languages. We have spoken languages, written languages, body language. Math is just another one. It's a very precise and powerful language, but it's a human creation all the same. Look at the history of counting. It didn't just appear. Early humans probably didn't have words for numbers. They might have used notches on a bone. One notch for one day, another notch for the next. This is a one-to-one correspondence. It's the beginning of the system. It's a human invention to keep track of things. Different cultures invented different systems. The Babylonians used a base 60 system. That's why we still have 60 seconds in a minute and 60 minutes in an hour. The Romans had their numerals, which were clunky for doing big calculations. The system we use today, the Arabic numerals with the concept of 0, was a massive invention. 0 was a game changer. The idea of a symbol for nothing allowed for place value and made arithmetic much easier. These are all inventions. They are systems and symbols created by people to solve problems. The symbol 5 is not the same thing as 5 apples. It's an abstract idea we agreed on. We could have used a different symbol. The rules of addition, subtraction, multiplication, division, we wrote those rules. We defined them. Think of it like a game. Chess, for example. We invented the board, the pieces, and the rules. A bishop moves diagonally, a knight moves in an L shape. These are not laws of nature. They are arbitrary rules we created, but once you have those rules, a whole world of logic opens up. There are good moves and bad moves, there are complex strategies and beautiful checkmates. The logic of chess is real and consistent, but the entire system is a human invention. The argument is that math is like that. We invent the basic rules, the axioms, things like a line is the shortest distance between 2 points. Then we see what logical conclusions we can draw from those starting rules. The whole structure of mathematics, from simple arithmetic to complex calculus, is just the result of playing this game according to the rules we set up. This view gets a lot of support from some strange parts of math. For centuries, everyone assumed that the geometry described by the Greek mathematician Euclid was the only possible geometry. It was the truth about space. His rules seemed obvious. Parallel lines never meet. The angles of a triangle always add up to 180 degrees. It seemed like a discovery about the very fabric of reality. But then, in the 19th century, mathematicians started playing with the rules. They asked, what if we change one of Euclid's basic assumptions? What if we say that parallel lines can meet? At first it seemed absurd. It was like saying 2 plus 5. But they followed the logic, and they found they could create entirely new geometries that were perfectly consistent. These are called non-Euclidean geometries. In one version, space is curved like the surface of a sphere. On a sphere, the shortest distance between 2 points is a curve, not a straight line. And if you draw a big triangle on a sphere, the angles add up to more than 180 degrees. In another version, space is curved like a saddle. In that world, a triangle's angles add up to less than 180 degrees. This was a shock. It turned out there wasn't just one true geometry, there were many. We could invent them. And the really weird part, Einstein later showed that one of these weird invented geometries, the one for curved space, was actually a better description of how gravity works in our universe than the old, obvious Euclidean geometry. This makes a strong case for invention. If we can create different competing mathematical systems, then it seems less likely that we're discovering one single ultimate truth. It seems more like we are building different tools for different jobs. Sometimes the old tool works fine. Sometimes you need a new one. Then there's the concept of infinity. We can talk about it. We can create symbols for it, we can use it in equations, but nobody has ever seen or touched infinity. It's a concept and idea we invented to deal with things that go on forever. It's a powerful and useful invention, but it's an invention nonetheless. It exists in our minds, not in the physical world. So the invention argument is strong. It says math is a creative human activity. It's a product of our culture and our history. We built it piece by piece over thousands of years. It's a beautiful and logical system, but we are its architects. It's a story we tell ourselves about the world, a very useful story, but a story still. Now, let's look at the other side, the idea that we discovered math. This view feels more mysterious, more profound. It says that math is not a human language. It is the language of the universe itself. Mathematical truths are objective facts, independent of human minds. They were true before we existed, and they will be true long after we are gone. We don't invent them, we uncover them. The strongest argument for this is what's sometimes called the unreasonable effectiveness of mathematics. Why does math work so well to describe the real world? It's a bit spooky. A mathematician can sit in a room, play with abstract symbols and equations, and come up with a theory that has no connection to reality. Then, years later, a physicist doing experiments finds that those exact equations perfectly describe how a particle behaves or how a galaxy moves. How is this possible? If math is just a game we invented, like chess, why would its rules so perfectly predict the flight of a rocket or the pattern of a snowflake? It would be like discovering that the rules of chess could also be used to predict the weather. It would be an insane coincidence. Take gravity. Newton came up with mathematical laws to describe it. And they worked. We used them to predict the orbits of planets with incredible accuracy. Then Einstein came along with his theory of general relativity. He used that weird non-Euclidean geometry. His equations were even more complex, and they made new predictions. They predicted that gravity could bend light. Years later, astronomers looked at the stars during a solar eclipse. They saw that the light from distant stars was indeed being bent as it passed by the sun, exactly as Einstein's math said it would. The math, an abstract thing of the mind, knew something about reality before we had even observed it. This happens all the time in physics. Quantum mechanics, the theory of the very small, is built on incredibly abstract and strange mathematics. Yet, it is the most successful scientific theory in history. The predictions it makes are accurate to an astonishing degree. It's the reason we have computers and lasers. So, proponents of the discovery view say this is not a coincidence. The reason our math describes the universe is because the universe is inherently mathematical. The physical world is built on a mathematical structure. The laws of nature are written in the language of mathematics. When we do math, we are deciphering that code. We are pulling back a curtain and seeing the underlying reality. Think about prime numbers. A prime number is a number that can only be divided by itself and 1. Like 2, 3, 5, 7, 11, 13, and so on. We can decide what symbol to use for them, but we can't decide which numbers are prime. That's a property of the numbers themselves. The fact that there are infinitely many prime numbers is a theorem, a truth we proved. But we didn't invent that truth. It seems to have always been there, waiting to be found. The distribution of prime numbers is still a mystery that mathematicians are trying to solve. They talk about it like they are exploring a hidden landscape, not just making up rules. And what about pi? The ratio of a circle's circumference to its diameter. It's approximately 3.14159. This number shows up everywhere, not just in circles. It appears in probability, in physics, and all sorts of unexpected places. We didn't invent the value of pi. We can calculate it, we can discover more of its digits, but we can't change it. It is what it is. It's a constant of the universe. This leads to the idea of a kind of mathematical reality. The ancient Greek philosopher Plato was a big believer in this. He thought that mathematical objects, like a perfect circle or the number 5, existed in a separate ideal realm. Our world is just a world of shadows and imperfect copies. A circle we draw in the sand is not a perfect circle. But the idea of a perfect circle is real and eternal. When we do geometry, we are accessing this higher realm of perfect forms. And this might sound a bit mystical, but many modern mathematicians and physicists feel something similar. They often speak of the beauty and elegance of a mathematical proof. It feels like they've stumbled upon a deep truth, not just arranged symbols in a clever way. They feel like explorers charting an unknown continent. The continent was there all along. They just drew the first map. So if aliens exist, would they have the same math? An advocate for discovery would say yes, absolutely. They might write it differently. They might use a different base system. Their symbol for pluses might look strange to us. But they would have discovered the Pythagorean theorem. They would know about prime numbers. They would have calculated pi, because these are universal truths, they are not human truths. They are just truths. This view is powerful. It gives math a sense of grandeur and mystery. It connects our minds to the very structure of the cosmos. It suggests that in our quest for knowledge, we are not alone. We are in a dialogue with a structured, ordered, and understandable universe. So we have two very different stories. One story says math is a human invention, a tool, a language. It's a product of our minds, our culture, our history. It's like a game we created, whose rules happen to be very useful for describing the world. The other story says math is a universal discovery, a feature of reality, a code. It's an objective truth that exists outside our minds. It's like a mountain range we explore, whose peaks and valleys were there long before we arrived. Both arguments are compelling. Both have good points. So, who is right? Maybe the question itself is the problem. Maybe it's not an either-or situation. Maybe it's both. Maybe math is both an invention and a discovery. Let's think about it in a different way. Let's use an analogy, the map and the territory. The universe is the territory. It's the real thing. It has real properties. It has patterns, structures, and rules. Gravity pulls things together. Energy behaves in certain ways. Space has a certain shape. These things are real and exist independently of us. They are the territory. Math is the map. A map is a human invention. We decide the scale. We decide what symbols to use for rivers and mountains. We choose the colors. We create the grid lines of latitude and longitude. The map is a human construct, a language of symbols designed to represent the territory. But for a map to be useful, it has to accurately reflect the territory. You can't just draw a river wherever you want. The river on the map has to correspond to a real river in the world. The better the map, the more accurately it represents the territory. So we invent the language of the map. We invent the symbols, the axioms, the rules of logic. That's the invention part. But what we are describing with that map, the underlying structure of the territory, is real and is being discovered. Let's go back to the number 3. Our brain seems to be wired to recognize patterns. It's a survival skill. Recognizing the difference between one predator and 3 predators is very important. So, we have this innate ability to perceive quantity, or what some people call number sense. We then invent a word, 3, and a symbol, 3, to label this perception. The word and the symbol are our invention. But the 3-ness of a group of 3 rocks is a real property of the world that our invention helps us grasp. We invented the label to describe something we discovered in our environment. The same goes for geometry. We see shapes and forms in the world around us. We see straight lines and light rays and flat planes on the surface of calm water. We invent concepts like point and line to abstract and idealize these observations. These concepts are the tools, the language of our map. Then we use this language to discover relationships that were there all along. And we discover that for any right-angled triangle on a flat plane, the sides have this special relationship. The Pythagorean theorem is a feature of the territory that our invented map allowed us to see clearly. This bridges the gap between the two views. It explains why math feels like an invention. Because the language, the symbols, the axioms, we did create those. Different cultures created different mathematical languages, just like different map makers can create different looking maps of the same place. And it also explains why math feels like a discovery. Because it works. A good map helps you navigate the real world. A good mathematical theory makes accurate predictions about the universe. The unreasonable effectiveness of math isn't so unreasonable if you think of it as a very, very good map of reality. The reason it's so effective is that it is constantly being checked against the territory. If a mathematical theory doesn't match experiments, it gets modified or thrown out. We are always refining our map. When the non-Euclidean geometries were invented, it was like someone realized you could make different kinds of maps. A flat map of the world is useful for a small area, but it distorts the poles. To map the whole Earth accurately, you need a globe, which is based on the geometry of a sphere. Einstein realized that to map the universe on a cosmic scale with gravity in the picture, he needed a different kind of map one based on curved spacetime. He invented a new map to better describe a feature of the territory that the old map couldn't handle. So, math is a creative process. It's a dialogue between our minds and the universe. We observe a pattern in the territory. We invent a concept, a piece of our map, to describe it. We then explore the logical consequences of that concept on our map. This exploration can lead us to predict new, unseen features. We then look at the territory again to see if our prediction is correct. If it is, our map gets better. This explains why math can feel so abstract and disconnected from reality, yet also so deeply connected to it. The abstract part is us playing with the rules on our map. The connected part is when the map proves to be a true guide to the world. So, is math a human invention or a universal discovery? The answer seems to be that it's a human invention that allows us to make universal discoveries. The story of humanity's attempt to understand the world. It's a story that started with notches on a bone and has led us to the equations that describe the Big Bang. We write the story, we invent the characters and the grammar, but the plot is already out there, waiting for us to find it. The question itself reveals our unique position. We are part of the universe. The matter in our brains was forged in stars. But we are also able to step back, in a way, and create abstract systems to comprehend that very universe. We are both inside the system and trying to draw a map of it, so perhaps the debate isn't about two opposing sides. Perhaps it's about two sides of the same coin. The invention is the human side of the coin, our creativity, our language, our ability to abstract. The discovery is the universe's side of the coin, its patterns, its structure, its deep and elegant order. You can't have one without the other. Without a universe that has some inherent order, there would be nothing to discover. Our math would be just a meaningless game. And without the inventive, pattern-seeking human mind, that order would remain unseen and unknown. The universe would be a book written in a language no one could read. Math, then, is our way of learning to read that book. We invent the alphabet and the grammar, but the story itself is the universe, and it's a story that we are still just beginning to understand. The journey is one of both creation and revelation, of building a language and seeing what it can tell us about the silent, structured reality all around us. It is the most human of activities and perhaps the most powerful bridge to the world beyond ourselves.